All right, guys, this is the Unit 6.1 notes. It is in the red packet, Unit 6 Congruent Triangles. We're going to be on pages 1 through 3. This is page 1. Today's learning target is I can use what's called congruency to find the missing sides and angles of figures. Okay, I can use congruency to find the missing sides and angles of figures. So congruent polygons are essentially, they're kind of like similar polygons, except similar polygons, if you remember, had same shape, different sides. Congruent polygons actually have the same shape and the same size. So it's like they're exact replicas of each other. So they're both triangles and they're the same size of triangle. Okay, that means their sides are congruent and their angles are congruent. So unlike similar polygons, their sides are not just proportional, they're actually congruent to each other. So they're the same shape and the same size. Okay. For this lesson, we are going to be using colors, or I'm going to be using colors. And so at one point in the lesson, I'll be using 5 different colors at once. So I would pause the video and make sure you have 5 colors if you'd like to join me on the color journey. All right, so this first one, I'm going to be using 3 different colors. It asks if triangle DJT, that's right here, is congruent to triangle FCR. That means that I need to list the corresponding parts. So here's how I do that. I'm going to pick a color for my first letters. So I'm going to do D is my first letter, F is my first letter. I'm going to highlight them D and F on my picture. Pick a different color. J and C. J and C. I'm going to highlight them on my picture. T and R. T and R. I'm going to highlight them on my picture. T and R. Okay, now that I've highlighted them on my picture, my first ones were the same, my second ones were the same, my third ones were the same. Now I can really tell which angles are congruent to each other. It really pops, right? Angle D would be congruent to angle F. Angle T would be congruent to angle R. And angle J is congruent to angle C. It really takes the guessing out of it, right? Now what about congruent sides? Right now none of our sides have colors, but we can give it to them. So let's start with green. Let's go from green to yellow. Green to yellow. So now we would know that DJ is congruent to FC, right? Because they're both green sides. Okay. So, sorry about that. My highlighter's kind of messing up right now. So DJ would be congruent to FC. Now let's keep going with our pattern, yellow to blue. Yellow to blue, yellow to blue. So then we would know that JT, the side JT, would be congruent to CR, right? Last one, we can finish with blue. The blue sides would be TD and RF, right? We could say that TD is congruent to RF. Okay, so pretty straightforward, right? Hopefully coloring it kind of helps magnify what's true about the picture. Let's try example 2. I would encourage you to pause the video and try this one on your own and then check your work after I'm done. But I'm going to need a 4th color for this one. If you'll notice here, that does not give us a congruency statement. We're actually going to have to find what it is. Here it gave us the congruency statement, but here it does not. But we can still color the picture without the congruency statement. Let me show you how. Let me pick a color for A. Okay. A has how many arc marks? Only 1. Only 1. What has only 1 arc mark over here? E. Okay. Now let's pick a different color. Pick a different color for B. Okay, B has how many arc marks? 2. How many arc marks over here? F. has 2. What about C? C has 3 arc marks. How many arc marks over here? G has 3 arc marks. And then finally, D has 4 arc marks, so H is going to have 4 arc marks. Okay? Once you've got that laid up, it's pretty simple to do the congruent angles, right? We could have angle A, that's green, is congruent to angle E, right? Angle B, that's blue, is congruent to angle F, that's the same. Angle C would be congruent to angle G. And then finally, angle D would be congruent to angle H, right? That's pretty simple. Now see if you remember how to do the sides. Like I said, I would really encourage you to pause the video if you haven't. Try to do this on your own. So what you're going to do next is you're going to go from green to blue, blue to yellow, blue to yellow, yellow to orange, yellow to orange, and then finally orange to green. Orange to green. Okay? So now it's pretty easy to tell the sides too, right? What's my green side? AB. What would AB be congruent to? EF. BC. What would BC be congruent to? FG, right? They're both blue. GH would be congruent to CD. They're both yellow. HE would be congruent to DA, right? Pretty simple, right? Not too bad. Finally, the congruency statement is we need to make it look like this. So we need to say something is congruent to something. Something is congruent to something. Well, let's just put these in some kind of order. Let's do A, B, C, D. A, B, C, D. Well, if we want that to be in a certain order, let's make sure we do that. So A was green, B was blue, C was yellow, D was orange. So we need to make sure that we put the same letters in the same places for the other figure. So what was green? E. What was blue? F. What was yellow? G. What was orange? H. Okay, so that would be our congruency statement. Not too bad. Hopefully those of you who really like colors, this is beneficial to you. Okay? Example 3. Example 3. Let's take a look. So now we have these triangles, right? We're trying to decide, are they congruent? Well, let's just first of all start naming some things we know about the triangle. Well, if they're going to be congruent, we need to have 3 angles congruent to each other and 3 sides congruent to each other. So let's just start naming what we know according to our picture. Okay, you might pause the video and try to name what you know and how you know it. I know that angle B, right here, angle B is congruent to angle D. I know that. Okay? I know that because they're both right angles, right? They're both right angles. What else do I know just based on the picture? Well, I know BC right here, BC is congruent to CD. How do I know that? BC is congruent to CD. Well, look at our picture. It's given to us. It's said that they are both 4. Okay, what about AB and ED? That's the same thing, right? AB and ED, it's told that they are both the measure of 3. Okay, so what else? So what do we know so far? We know an angle, we know a side, we know a side. What else do we know? Well, there's this side and this side. So we know AC is congruent to CE, right? Why do we know that? Well, it's given in our picture, and these are called tick marks. Tick marks. Okay. Cool, so we know another side. So we actually know that all 3 sides are congruent already. We know one angle. What else do we know? It gets kind of tricky, huh? Well, what about this angle and this angle? If I told you that I know that those are congruent, would you know why those are congruent? Angle BCA is congruent to angle ECD. Angle DCE. Why are those congruent? Starts with a V. Vertical angles. Vertical angles. So I know that those two angles are congruent. So that's another angle. And I could also tell you that this angle right here is congruent to this angle. Again, I'm just going to tell you because I can't brainstorm with you in real class right now. But the reason that angle A right here, it would be congruent to angle E, maybe you know it, is because all angles in a triangle add up to 180. So like for instance, let's say that this was 90 degrees. This is 90 degrees. We know that because they're both right angles. If we know these are congruent to each other, let's just make up a number. Let's say these are both 20 degrees. 20 degrees. If this is 90, this is 20, how do we find the missing angle here? Well, we subtract by 180, right? 180 minus 90 minus 20, because all my angles add up to 180. You give me 70. So this would be 70 degrees. And wouldn't we end up doing the same math over here? We'd end up doing the same math. So this would also be 70 degrees. So because the angles in triangles both add up to 180 every time, we can know that that angle is congruent as well. Finally, we got to come up with a statement. So let's try to figure this out. We know B and D are congruent. We know this angle right here and this angle right here, they're congruent. And we also know that A and E are congruent. So we can make a statement. Let's start with this one. We can do ABC, so green, blue, yellow. Triangle ABC is congruent to another green, blue, yellow. EDC. EDC. See how we did green, blue, yellow? Green, blue, yellow? EDC. This is because they are congruent. The definition of a congruent triangle is that all three angles are congruent and all three sides are congruent. And we just proved that with all that information. So this is going to be important because next lesson we are going to be focusing on proving that triangles are congruent to each other. Okay, let's look at example 4. All right, it has given us a congruency statement. So anytime we see something like this, I want you to color code first. So let's go ahead and color code. A and M. Let's do green. A and M. Let's keep going. Let's do blue. B and N. B and N. Let's do C and O. C and O. Okay, we're getting somewhere. Let's do our sides as well. Let's do green to blue. Green to blue. Green to blue. Again, I'm kind of going through this fast because I already taught you how to do this a couple times now. Yellow to green. All right, sweet. So now we have this all labeled. Okay. It is asking us to find the values of x and y. Okay. The whole 2x plus y thing kind of intimidates me. That looks a little bit crazy. So let's just focus on y for now. Okay, let's look here. 5y minus 13, that is a yellow line. Okay, we can set that equal to anything else on the yellow line over here. If this is the yellow line and this is the yellow line, let's make an equation. 5y minus 13 equals 32. Yellow line, they match. Anytime they match, you can set them equal to each other. Same with angles. Now we have an equation and we can solve this for y, get y by itself. Add 13 on both sides, we could get 5y equals 45. Divide both sides by 5, y would equal 9. Okay, so we've got y. We've got y. Interesting. Okay, so if we know what y is, it looks like we kind of got to deal with this stuff, don't we? Interesting. Well, we know that this is actually pointing to this angle right here. This is my blue angle. So 2x plus y represents my blue angle. My blue angle over here is represented by this blank spot. We don't know the measure of that angle right now. Okay, But we're trying to set 2x plus y equal to something. We want to know what that angle is. How do we find the measure of that angle? Well, if you see here, we know the other two measures of those angles in that triangle. So we can do the same thing we were doing earlier. 180 minus 45 minus 46. If you put that in the calculator, you get 89 degrees. So the measure of this angle right here is 89 degrees. Okay, so I could set the measure of this angle, 2x plus y, to equal to 89 degrees. Okay, cool. We don't really need the degrees. That's going to confuse us. 89. 2x plus y equals 89. So now we can try to solve this, but this is kind of confusing because I have this y. But what else do we know about y? We know, let me try to find a, there we go. Y equals 9, right? So we can replace this y with 9. Okay, let's keep going now. 2x plus y, 2x plus 9 equals 89. We replace that 9, replace the y with the 9. Okay, 2x plus 9 equals 89. Now we just solve. 2x equals 80, divided by 2 on both sides. X would equal 40. Okay, so in that one, it's kind of like a big puzzle. This is like a classic geometry problem. We found y first, and that helped us find x. Okay, x equals 40, y equals 9. All right, guys, last example. Example 5. Here we're going to need 5 colors. So let me make sure I've got 5 different colors. I do have 5 different colors. All right, so in the diagram, polygon, blah, 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 congruent to polygon, blah, blah, blah. Lots of different letters. Anytime we get this, let's color code first. I'm going to even write that down. Color code. Always, first step. So J and U. J. And by the way, you can fast forward through this if you want to not witness me color coding all this. K and V. K and V. L. L. L and W. L and W. M. If you didn't know, I'm actually colorblind, so this is pretty challenging for me. N and Y. N and Y. All right, cool. So we got a color code. Let's color code the sides as well. So J to K would be green. U to V would be green. Let's get yellow. Keep going. All right, so I know this is time consuming, but it does help you. All right, so I've got my picture color coded. So now I just obey my colors. Okay, it says, which of the following statements are true? Well, side KL. What color is side KL? It is yellow. Yellow side. Side UV. Side UV is green. Are those the same color? They are not. So are they congruent? They are not. Same color, not congruent. Side WX, what did I label that one as? Orange. Side WX is orange. Side JN is pink. Side JN is pink. Are those the same color? They are not. So they are not congruent. Side XY. Side XY. I labeled that as blue. Side JK. I labeled that as green. Are those the same color? They are not. So we have yet to find one where they are the same. What about side JN? That looks like it's pink. And then side UY is also pink. So we finally found a winner. This one would be true. They are the same color, right? So really just D is true. All right, last problem. Letter B. What is the measure of side VW? Okay, well, let's look at our picture. VW is right here. It's yellow. Okay. So wouldn't it be logical, couldn't we just say that VW and LK, wouldn't they be the same? VW and KL. Whoops. VW would be congruent to KL, right? They're both yellow. So can't we just plug in the measure of KL? Oh no, we don't have a measure for KL. It's blank. So we can't, that would have been awesome though, right? Well, we do know that the perimeter is what? The perimeter of each polygon is 47 meters. So how can we use that to help us? Okay. If the perimeter of this figure right here is 47 meters, we could, and we know all the other four, that means that all the angles add up to 47. So we could do 47 minus all the numbers that we have left to find the yellow. So 47 minus, so we could do 47 minus all the numbers. So 47 minus 8, 47 minus 12, minus 9, minus 13. And if you put that all in the calculator, you get 5. So basically the measure of this is 5 meters. So if KL is 5 meters, then VW would also be 5 meters. And our answer would be 5 meters. Okay, so we basically had to figure out what this missing yellow one was to find out that yellow one. All right, that is it. Go work on the practice, pages 4 through 6. You totally got this. Good luck.